Okay, so we're gonna go ahead and do. This is Expert TA. This is what for Chapter 4 under the week, problem 3A. Um, so yeah, we're gonna kind of explain that. So this is 3A. Okay, so this problem deals with a ball, a football, going up, and then the ball is at this position again, and it wants us to find the time it took to travel that distance. Now, the variables that it gives us, lighter color here, it gives us that it's at this position, it's at h, and it also gives us the vy and vx at this position. So it's going to tell us the components, because really it's, it's kind of traveling in that funky other thing, but at this point, it's going at vx and vy, and that's kind of, that's going to help us a lot. So I'm going to go ahead and use the variables that it generated for me. Yours will probably be different, and if they're not, well, then you get a nice freebie. So h is going to be 1.3, vx is going to be 16, and vy is going to be 1.75. So for this problem, and really for the 3b is, well, I'm sorry, this is 3b. I'm sorry, that was my bad. So for this and 3a, vx really doesn't matter. What we're looking at is vi, because as we kind of learned, throwing a ball straight up and it coming down, it's going to take the same amount of time as it would if it if we kicked it with 16 meters of horizontal force. The time is still going to be the same. So what we're looking at, and what we want to figure out, is how long is this ball in the air. So the first thing, so what I'm kind of looking at it as, again, let's switch colors here again. So at this point right here, right, the velocity is going to be 0. And we know that. We know that for a fact. That's just kind of, okay, that's where it's going to stop. So what I'm looking at is I'm going to split this up. I'm going to find the time here. So this is our apex, and then it falls down, and then we got the ball here, and, blah, blah, blah. I want to find out what's this height, and I'm going to label this height 1. The other thing is just height. So in order to find that, how far the ball goes, we can use the formula vf squared equals vi squared plus 2ab. Because now remember, we know the vf. The vf is going to be our, what that ball was at. The vi is going to be 0 because we're at the apex. And we know, too, and we know the acceleration, 9.8, and d is what we're trying to figure out, because d is going to be h1. So we plug everything in, we're going to get 1.75 squared equals 0 plus 2 times 9.8 times d. Now I'm not going to deal with all the algebra, you can solve that, but what you should get is 1.56 equals d. So now we know, okay, so now we can say, okay, well this whole thing right here, h1 equals 0.156. Well, now I know that the h max, that the highest that this ball could reach, is going to be h plus h1. So, because, all I'm saying here is pretty much is this length plus this length equals the full length. That's pretty difficult to argue with. So I'm gonna go ahead and make a new page here, since we're filling up on the room. Okay, so we got our ball, we're at there, and we discovered that our h max is equal to so this is just me plugging them both together, 1.46. And to do that, I just did 1.56, which was our h1 plus the h max, 1.3. They gave me that. That was the initial thing. So boom. All right. So I know this is the apex. So, well, great, because what this can tell me is I can figure out how long was the ball in the air to to get to that distance. And something that's very, this is not a formula that we covered in class, doesn't make it any less of a valid formula really, is this is technically one of the kinematic equations of vi plus vf over 2 times t. So this is going to give me my d. If you haven't seen this, if this looks weird, we didn't cover it in class, but technically, if you move around stuff, or one of the other three we got, you'll get this. I just like remembering this because I think it's, you know, a handy formula and you don't got to screw around with all the other stuff. So, you know, just plugging in for that, well, I know the H max is 1.46 because I know the ball from here to here traveled the distance of H max. So then I say, okay, well, what's the VI? I don't know the VI. Sorry, I had to pause it there for a second. I did jump the gun here. First, before we do that, we need to find out what the VI is, obviously, because otherwise we're going to have two variables and we're never going to be able to solve it. So an easy thing to do that is we're just going to use our same equation here of VF squared equals VI squared plus 2AD. Well, now I know what my max is. So if I'm measuring it from here to the apex, if I want to figure out what's how much initial velocity would be needed in the y direction, you know, what's my Vy here? Well, I know Vf, I know the velocity final once it gets up to here is going to be 0. Vi squared is what I'm trying to figure out, so plus 2, 9.8, and I know that this is going to come down here, this 1.46. I don't know, it probably was off the screen, but trust me, that's what it says. So then using simple algebra, we should get Vy equals 5.35. So this is how much initial velocity was caused at that ball in the y direction. Not here. This is not the component, you know, that vector force. This is the y vector. This is how much velocity was in the y direction, straight up vector. So now, since I like to jump ahead of myself, we can plug that into here. So 1.46. Let's get back to pink, purple, whatever that is. 5.35 plus 0 over 2 equals t. Now, you solve for that, and you're going to get, I'm running out of room here again, jeez. So you solve for that, you're going to get t is equal to 0.55. So, now remember, this is just how long it took the ball to reach that height. It is not how long it took the whole thing. It's how long it took to reach that point. You know, because the acceleration I was going to cause it, so how long it took that long, 0.55 seconds. So let's call that T1. Well, now we need to figure out T2. How long did it take to travel that little bit? Because we know the ball's there. Well, in order to figure that out, we know previously, if you remember back, remember how our first D was 0.156, and we're going to just, you know, let's use sig figs, 0.16. So let's just use that same equation of D equals Vi plus Vf over 2 times T. So now let's say, okay, well now we're only going 0.6, and now what was our Vi? Well, our Vi was 0 because we were starting at the top, and you know we didn't have any velocity here. What was our Vf? Well, the Vf that they gave us was 1.75. Now remember, all of this is in the y direction. We're just worrying about the y, no x's. Very, very key point there. And then so that's times T. Now, you know, again, just using simple algebra, we're going to get T equals 0.18. So this is T2, technically, right? So now, if I just add these two suckers together, 0.55 plus 0.18, I'm going to get 0.72. You know, an expert's TA answer was 0.73, but, you know, I mean, it's close enough. So 0.72 in this problem would be the total seconds it was in the air, because this is how long it was in the air this first half, which has how long it took to get to that initial height, and then this is how long it was in the air, the second half of how long it took to reach that velocity of 1.75 meters per second. If you're still not getting it, let me know. There's not much more I can do besides video, but I'll definitely try to answer any questions.